Today we're looking at section 1.2, exponents and powers. A couple goals: we're evaluating expressions containing exponents, and we're using them in real life problems. Begins on page 9. Set of definitions. First one is a power. It's the result of a repeated multiplication, like 2 times 2 times 2. 2 times 2 times 2 would give you 2 to the third power. The result of a repeated multiplication. Again, don't copy down word for word definitions, just in a few words what it means to you. Base is the number of the variable used as a factor in repeated multiplication. So if you had 2 to the third power, the base would be this number here. The factor, the large number as you see it, the one that's getting repeated is the base. The exponent is the number of the variable that represents the number of times the base is used as a factor. Again, 2 to the third power, the exponent is the small number that's raised up. Most people are familiar with that. It's how many times the base is being multiplied, or the amount of times it's being multiplied by itself. Don't confuse this as meaning 2 times 3. That's the most common mistake I see. 2 to the third power means, again, 2 times 2 times 2. Grouping symbols indicate which order of operations should be performed first. Most people understand what parentheses are. When we do PIMDAS, so please excuse my dear Aunt Sal, that's the first thing people think of, parentheses, because of P. But these are also grouping symbols. Brackets, when you see them, or the things that look like this, the braces. Those are grouping symbols. The rule with grouping symbols, though, is you work the innermost set first. So if you have a set of brackets with some numbers inside of it, and then a set of parentheses inside, you work the innermost ones first, the parentheses and then the brackets. Example number 1 says express the meaning of the power in words and then with numbers. The first one says 15 with an exponent of 1. You don't read it like that. I'm just reading it like that because that's the way it's written up here. You read it just like it's written here. 15 to the first power. The meaning of it is 15 times itself only one time. 15 times itself only one time. 15 to the first power. B says 5 with an exponent of 2. You read that as 5 to the second power, or here's the shorter version, 5 squared. That 2 as an exponent can be written as 5 squared. The meaning is 5 times itself 2 times. 5 times 5. I mean by that, it's represented 1 times, 2 times. 15 was represented 1 time. And then the third one, C, says 6 with an exponent of 3. You read that as 6 to the third power, or again, the shortened version is 6 cubed. Represented as 6 times 6 times 6, 3 times. 6 cubed represented 3 times. Example number 2 is evaluating powers. X to the 5th power, you read it just like that, when X's value is 2. Substitute in the value of 2 in place of X. So we have 2 written there to the 5th power. On the next line, that means we're multiplying 2 times itself 5 times. Notice it's 1, 2, 3, 4, 5. That does not mean 2 times 5. You give me the number 10, you're going to come up with the wrong answer. When you multiply 2 times itself 5 times, you get the number 32. 32. Example number 3 says evaluate the expression a minus b to the 4th power when a equals 5 and b equals 3. A minus b to the 4th power, plug in a's value of 5 and b's value of 3 in place of a and b. Notice it's in parentheses 5 minus 3. That needs to be done first. We'll get to that in just a second. Look to the right. It says substitute 5 and 3 for b. You have to do 5 minus 3 first and get 2. Then 2 is being raised to the 4th power, which means 2 times itself 4 times. 1, 2, 3, 4. Raised to itself 4 times. And when you multiply 2 times itself 4 times, you get 16. Example 4 says evaluate the expression a squared plus b squared when a equals 7 and b equals 4. In place of a, plug it in 7. In place of b, you plug it in 4. So 7 squared plus 4 squared. That means 7 times itself 2 times, which is 7 times 7 is 49, and 4 times itself 2 times, which is 16. 49 plus 16 gives you the number 65 when you add them. And then you have a checkpoint at the bottom. It says 3n plus n to the third when n's value is 5. Notice we have to plug in 5 in 2 different spots. The first one, 3 to the 5th power, is where we're going to plug the first n in. Plus, n's value is 5 to the 3rd power. So 3 to the 5th power means 3 times itself for 5 times. Plus, 5 to the 3rd power means 5 times itself 3 times. So then we do 3 times itself is 9 times 3 is 9. So we have 9 times 9 times 3. And we have 81 times 3 here. So we have 243 that comes out of that one. 5 times itself, 3 times 5 times 5 is 25 times 5 is 125. So we have 243 plus 125. We wind up with the answer 368. Okay, number 2 on the checkpoint problem says 3c to the 4th minus 18, and it's all being raised to the c exponent. Then it says when c's value equals 2. So we have to plug in c again in 2 separate places. We have to plug it in for the base c, and we have to plug it in for that exponent c. So we have 3 times, we'll plug it in 2 to the 4th power, minus 18. And all of that is inside of another set of grouping symbols. And then it's being raised to the c power, which we said is also 2. So if you go through what we did there, we just substituted in given values. Simple. So 2, you have to do what's inside the innermost thing first. So our innermost thing that we have to take care of, if you listen to PEMDAS, or please excuse my dear Aunt Sally, you got to take care of exponents inside parentheses first. So we have 2 to the 4th power. So what we have here is 3 times 2 times 2 times 2 times 2, because it's to the 4th power, minus 18, and all of that is still inside of a grouping symbol, which is all being squared. So 4 times it's 2 times itself 4 times, 2 times 2 is 4, times 2 is 8, times 2 is 16. So now we have 3 times 16 minus 18. All of that's still inside of a grouping symbol, and it's squared. What you have to do next is 3 times 16, because you have to do parentheses before you do subtraction. 3 times 16 is 48. It's still minus 18. It's still inside of a set of grouping symbols, and it's squared. 14 minus 18 is the number 30. And that number is being squared. And 30 squared means 30 times 30, which is the number 900. And that's the simplified version. So if you went through and you labeled everything you did here, we substituted in the given value. That's what we did for the first one. Then what we did was we did exponents to simplify. So we just evaluated exponents. And again, that was just to simplify. We just starting to simplify at that point. And that's actually to go to the next step from both of them there. And then for the next step, we multiplied 3 times 16. So from here, we multiplied because we were simplifying. And then from that step, we subtracted because we were simplifying. And then finally, again, we evaluated exponents. We multiplied 30 times 30. So we did exponents to simplify.